Plastic waste is generated at a rate of 234 pounds per person each year in the United States. In 2015, the country generated 262 million tons of waste, and since plastic started being made in the 1950s, humans have globally generated 8.3 billion tons of plastic waste. The EPA reported that in 2015, only 9.1% of plastic waste was recycled, 15.9% was combusted with energy recovery, and the remaining 75% was landfilled. This problem is only being made worse as more plastic waste is accumulating in the United States. This accumulation of waste plastics can be seen on a global scale as well. In places like China, where a large percentage of the world's waste plastics was imported, has recently implemented a plastics import ban that has left many countries with little to no infrastructure to deal with plastic waste. This accumulation is harming the environment, wildlife, and marine life by acting as a form of pollution, as it takes hundreds to thousands of years for plastics to decompose. In order to alleviate the amount of plastic waste accumulating in the country, the Green Chemistry Research Group has developed a two-step catalytic process that produces carbon dioxide, hydrogen, and syngas through a gasification process using polystyrene waste. Using this two-step process as a basis, the Advanced Process Synthesis Development Group at UD Chemicals was tasked with designing plans for a large-scale process that is capable of treating 10,000 tons per year of polystyrene waste and will produce hydrogen and syngas. Now, this process does have a lot of different types of impacts, so starting with global impacts. Gasification of waste plastics is a process that can be seen in many parts of the world and is usually found in industrial sites with plastic wastes. Dump sites in places like Thailand have been used to test the viability of this process. And this process of handling waste plastics is better in some ways than mechanical recycling, which just turns old plastic products into new plastic products, because it is not necessary to separate plastics based on composition for gasification. This concept is being used in locations such as landfills because it has less of a negative environmental impact than simply leaving the plastic to decompose. As the amount of plastic and the pollution associated with it increases, more landfills and industrial sites could attempt to convert their waste plastics into useful resources like syngas. Some economic impacts. Syngas production from gasification of waste plastics and the usage of syngas is also a rapidly growing market around the world, especially in the Asian Pacific regions. Globally, in 2014, the world produced 116.6 thermal gigawatts of syngas. Comparing that number to the 42.7 thermal gigawatts of syngas that was produced in 1999 is an example of this growing market. Additionally, in the first quarter of 2019, syngas was selling for 10 cents per cubic meter. This shows the growing prevalence of syngas as it is a clean energy source that people are actively pursuing. The manufacturing of syngas helps use waste plastics that could otherwise pollute the environment and provides a clean, inexpensive, environmentally friendly alternative fuel source to fossil fuels. Now, speaking of environmental impacts, the overflow of plastic waste has caused severe degradation to the environment. Marine life is often injured by entanglement or ingestion of plastics. In addition to the physical hazards associated with plastic, it also poses potential chemical threats in the environment, such as an accumulation of the toxic chemical ingredients found in plastics. During the gasification process, polystyrene is decomposed into syngas. Since plastics can be highly volatile and contain organic polymers, there is a possibility that harmful tar is produced in this process. However, gasification also reduces the amount of plastic waste in landfills and polluting bodies of water, so if designed properly to mediate this tar pollution, this process will help protect the environment from the increase in plastic pollution. So now we'll move on to our proposed process. Now, the gasification of waste plastics starts in a reactor vessel. The reactor that was chosen is a conical spouted bed reactor, or a CSBR. The CSBR is able to pyrolyze the waste plastics into hydrocarbons in an efficient and safe fashion. Pyrolyzation is when materials are thermally decomposed at high temperatures, and the CSBR operates at 500 degrees Celsius. The hydrocarbons from this process are then heated to 800 degrees Celsius and sent to a steam reformer. Inside this reformer, high temperatures and the presence of a catalyst convert these hydrocarbons into hydrogen, carbon monoxide, and carbon dioxide gases. Now, syngas, our desired product, is a mixture of only carbon monoxide and hydrogen gases. So this product stream is then cooled, but other impurities are still present after the reaction in the steam reformers. So this mixture requires a series of separation processes to achieve the desired purity of the final syngas product. A decanter is a separator used to separate water from the desired products based on a difference in densities. Separation processes are generally not perfect, so an adsorber is used to separate any water not separated by the decanter. Then a flash tank is used to separate any hydrocarbons from the desired products. This separation is based on the difference in boiling points. Again, an adsorber is necessary to remove any hydrocarbons not separated by the flash tank. A third adsorber is then used to separate carbon dioxide from the desired products with the help of nitrogen. This product is then compressed and cooled in an alternating series of compressors and heat exchangers. The final purification is obtained by the use of membranes that separate the mixture based on particle size. Nitrogen that is separated from the desired final syngas product is recycled back to the process to be used again. A membrane is then used to separate out excess hydrogen gas from the syngas so that both products can be sold for profit. Now, there are some safety issues associated with this process. A few of the chemicals and compounds associated with the gasification process have adverse effects on humans and the environment. For example, when broken down, polystyrene can contain benzene, a known carcinogen. Benzene also does not break down readily in the environment, which could eventually lead to ingestion by another living organism, causing potential sickness or death. In terms of the reaction, if polystyrene was accidentally released by a company making syngas, whether by a spill or plant explosion, this could cause many environmental issues. Furthermore, carbon monoxide and carbon dioxide are also not without risks. If not properly vented or collected, people working around the products of the gasification process could be at risk of carbon monoxide poisoning, as well as asphyxiation from the high concentrations of any of those gases. Hydrogen is also a flammable gas, and if exposed to an ignition source, the potential for explosion is inevitable. In addition to the risks associated with the chemical species of this process, high temperatures in the process also represent a potential safety hazard. Temperatures in the ranges of 500 to 800 degrees Celsius are prevalent within this process and pose a safety hazard for operators using this equipment. Temperatures this high can also easily cause a fire, and moreover, this process produces products that are in the gaseous phase, and there is a potential hazard for pressure to build up in the system, which can cause ruptures or even explosion within the equipment. Furthermore, the syngas product is to be compressed to a high pressure of 20 bar, so adequate safety measures will need to be in place to mitigate the risk of explosion or rupture of any of the process vessel or product containers. So given the potential global, economic, and environmental impact this process could have on decreasing the amount of plastic waste, we think this process is a desirable project to pursue. If this process is successfully adopted, one day plastic pollution and fossil fuel reliance may be an issue of the past.